In this lecture, we are going to create a program called addition program. So basically what this program do is that it is going to, given any two numbers, this program will simply add the two numbers up and print out the result. So I have already created a file. I have named it addition.c. I have imported the standard input output header file stdio.h, and I have defined function main. But before we start coding this particular program, we need to understand what is called variables and identifiers. So let's take a look at what are variables and identifiers. A variable simply means a location in a computer memory. So whenever you heard a variable, it simply means a location within a computer memory. So when we create a variable, the computer will create a space, will allocate a space within its memory and give it the same name that we assign to that our variable. So a variable has an address in the computer memory. So for instance, when we look at this an analogy of a variable, let's say this box is a variable. So this box exists within the computer memory. So we can see that the name of this particular variable is number 1 and the address is 1000 and the value stored within this variable is 23. So a variable has an address in a computer memory, which in this case is 1000. And the name we give to a variable is referred to as an identifier. So in this case, number 1 is identifier. Excuse me. In this case, number 1 is identifier that we give to a variable. So identifier for this variable is number 1. So identifier simply means a name. So any name that we designate to our variable is referred to it as identifier in programming terminology. And we follow the following rules to name an identifier. It can consist of letters, digit, and underscore, but it must not begin with a digit. Like in this case, our number 1, it mustn't begin with the digit 1. We can see it consists of the digit 1, but it must not start with the digit 1. And also C is case sensitive. So number one with uppercase letters and number 1 with lowercase letters are two different identifiers. So now that we have understood what a variable is and what identifier is, let's proceed and create our addition program. All right, so the first thing that I'm going to do, we are going to prompt the user of this program to enter two numbers so that the program will add the two numbers up and give the result to the user. So I'm going to make use of print function. And this semicolon is what we refer to as a statement terminator. This colon is a statement terminator, just as in a normal English writing we have a full stop at the end of a sentence. In C programming, at the end of every statement we put a statement terminator. So not putting a statement terminator is a syntax error. So we are going to have an error and your program will not compile. So at the end of every statement, make sure you put a statement terminator. All right. So now I'm going to make a prompt, print out this string, prompting the user to enter two numbers so that we can add the two numbers up and print out the result. So enter two numbers. Now this prompt will print out this message, enter two numbers, so that the user will enter the two numbers. But our program does not know what to do with these two numbers. So the next thing that we are going to do, we are going to create a variable so that when our program get hold of those two numbers, it know what to do with these two numbers. So I'm going to create the first variable, int number 1. So here I created a variable of integer data type, and we know integer are whole numbers that do not have any fractional part. So we are saying that number 1 is an identifier, as we have seen earlier, and is also a variable, which is a storage location within a computer memory. So we are telling the computer carve out a space within your memory and give that space an address and name that space number 1. We are going to give you a number to store in that particular space, and the data type of that value that we are going to give you to store in that particular location is going to be integer. So that is what we are doing in line number 11. So the computer will do just as we commanded it to do. So I can add a comment declaring number 1 as integer. So the next thing I'm going to, since we are adding two numbers, I'm going to declare the other number also as well. So declaring number 2 as integer also, as integer. All right. So now our computer at this line number 2 have created two variables, which are memory location. We'll have capped out a space within its memory and assigned a name to those two locations, number 1 and number 2, and as well, and give them also addresses. All right. So now the next thing, now we are going to make use of another function within this standard input output header file, a function that will now get those two numbers from the keyboard. So the user is going to enter those two numbers making use of a keyboard. So when the user enters those two numbers, this particular function would get hold of those two numbers and make those two numbers available to our program. So the name of that function is called scanf. So scanf. Now scanf, the first thing we are going to write what we call format control string. So this double quotation contains what we call a format control string, and within this format control string we have what we call a conversion specifier. So this %d is called a conversion specifier, and this is a conversion specifier for a decimal integer. So and this %d just like a placeholder, so just acting as a placeholder, and it is going to replace with this %d with this %d, we are telling the scanf that you are going to be absorbing, you are going to expect a decimal integer from the keyboard. So the scanf function will now expect an integer, get hold of that integer, and then decimal integer in this case, since we are using conversion specifier %d, and then it's going to say it is like a placeholder, and then it's going to replace it with what we have after this particular quotation. We have a comma, and then I'm going to put address of operator, and then the name of the variable number 1. So in essence, what I'm saying, I'm telling the scanf that this number 1 is a decimal integer, and you are going to get a value which is integer from the keyboard. Get hold of that decimal integer and place it in a location number 1, in the address of number 1. Remember, we have already declared a variable in line number 11 now, and I have said earlier, and we have seen it earlier at the beginning of this lecture, that a variable has an address. So here we are referencing the address of number 1. So we are telling it to go to memory at that particular address, store the value which is going to be decimal integer that you are going to get from the keyboard. So basically that is what we are saying. You are going to get a value, and that value is going to be decimal integer. Get hold of that value and replace it and put it in address of number 1. So this ampersand is called address of operator, and it is used to reference address of a variable. So here we are using it to reference the address of number 1 variable. So that is why we didn't just put number 1, because we don't need number 1. In this case, we need the actual address location where number 1 exists in the memory. So we are referencing that particular address, and we are going to store the value that we are going to get from the keyboard and store it in that particular location. And then the next thing, we are also expecting another decimal integer, which is number 2 in this case. So the second conversion specifier is for this other decimal integer, which is number 2. So number 2. All right. So at this line number 14, our program has gotten hold of number 1 and number 2. Now the next thing we are going to do, we are going to start making use of this number 1 and number 2 straight away. By now, we are going to recreate another variable that we are going to store the result of adding these two integers. I'm going to call it sum. Let me declare it as integer, and I'm going to call it sum. Now we have declared a variable sum, declaring a variable sum, declaring a variable sum, declaring a variable sum. So now we are going to say sum is number 1 plus number 2. So we are summing the two numbers, number 1 and number 2. So at line number 18, we have already added the two numbers up. So we have added the two numbers, which is the main objective of this particular program that we are creating. So now after, we would love to make the program the result available to the user. So now we are going to output the result. All right, so the sum of these two numbers, the sum of this okay, let's also print out the number. The sum of these two numbers, the sum of number 1 and number 2 is from another conversion specifier. So we are saying the sum of, and then we have conversion specifier. So this conversion specifier, the first conversion specifier, will look for the first number after this comma, and then substitute it with the particular conversion specifier. As I have already said earlier, this conversion specifier is like a placeholder. So whatsoever is after the first value after this comma is going to be substituted. Is going to substitute this first conversion specifier. So, and that is number 1. Because number 1, yes, the value of number 1, and so number 2, and then we have finally the sum of number 1 and number 2 is sum. Whatsoever the sum is sum, right? So now we are done with this particular program. So now let's go and run this program and then see whether if we have error, we'll come back and debug the error, get rid of the error, and then compile our program and run our program. So I'll go to the terminal now. So here I'm at the terminal. Let me navigate to the folder where I have this particular file, cd right. CD. All right. So ls. Right. CD. So let me clear ls. So we have it as addition. So I'm going to make use of my. Let me increase the font. GCC of addition. And then I want to output it as addition, So I'm invoking GCC compiler as you have seen earlier. I want it to compile this addition.c, and then the final result, the final output, I want it to have the name addition only without the .c extension. You can give it any name you like, but here in this case I'm returning the name without the .c extension, since it is it's now an executable. It has now been converted to an executable. It's no longer a C source code. All right, so let me run it. So I have successfully compiled it, and I'm not having any error. So I'm now going to run the program. To run the program, okay, let's see ls. Now we have addition. As you can see, it is in green, meaning that it is now an executable. So whenever, usually in Linux, whenever you see any file in green, it means that it is an executable file. And to run executable file, we just put this. We're telling the operating system that within this particular directory // we want to run a particular executable, and that executable is addition. So I'm going to hit enter. So enter two numbers. I'm going to enter two numbers, 23, 45, and then the sum of 23 and 45 is 68. So our program has run successfully. So thank you.